Fundamental of GIS. GIS people, number 33. Her name is May Yuan. May Yuan and new forms of representation. May Yuan received her Bachelor of Science degree in Geography from the National Taiwan University, where she was attracted to the fields of geomorphology and climatology. Continuing her fundamental interest in evolution of processes, she studied geographic representation and temporal GIS and earned both her master's and a PhD degrees in geography from the State University of New York at Buffalo. Currently, May is an associate professor of geography at the University of Oklahoma. Severe weather in the southern plains of the United States has inspired her to re-evaluate GIS representation of geographic dynamics, the complexity of events and processes at spatial and temporal scales, and GIS applications in meteorology, weather, and climate. She investigates meteorological cases, convective storms, and flash floods to develop new ideas of using events and processes as the basis of integrated spatial and temporal data in GIS. Her publications address theoretical issues on representation of geographic dynamics and offer conceptual models and prototype GIS to support spatial temporal queries and analysis of dynamic geographic phenomena. Her temporal GIS research goes beyond merely considering time as an attribute or annotation of spatial objects to incorporate much richer spatial temporal meaning. In her case study on convective storms, she has demonstrated that by modeling storms as data objects, GIS is able to support convective storms. GIS is able to support information query about storm evolution, storm behaviors, and interactions with environments. May developed a strong interest in physics in early childhood. Newton's theory of universal gravitation sparked her appreciation for simple principles that can explain how things work, and for the use of graphical and symbolic representation to conceptualize complex processes. Planck's quantum theory and Heisenberg's uncertainty principle further stimulated her thinking on the nature of matter and its behavior at different scales of observations. Shaped by Einstein's theory of relativity, May developed her world view as a four-dimensional space-time continuum populated with events and phenomena. Before she pursued her career in GIS science, May studied fluvial processes and developed a model to classify waterfalls and explain their formation. She went to study paleoclimatology by analyzing soil and speleothem sediments. Both studies, as well as her dissertation research on wildfire representation, reinforced her interest in developing conceptual models of processes and examining the relationships between space and time. Since she moved to the University of Oklahoma, a suite of world-class meteorological research initiatives has offered her unique opportunities to extend her interest in physics to fundamental research in GIS science, through meteorological applications. Weather and climate offer rich cases that emphasize movement, processes, and evolution, and pose grand challenges to GI science research regarding representation, object field, duality, and uncertainty. May enjoys the challenges that ultimately connect to her fundamental interest in how things work.